Welcome to AI Frontiers. Today we explore finding needles in digital haystacks, a curated journey through 94 cutting-edge information retrieval papers published between October 16th and October 31st, 2025. Discover how the latest advances in search and recommendation systems are driving new levels of efficiency, personalization, and trust, shaping the future of intelligent information access. This presentation navigates the future of search. It begins by examining why information retrieval is fundamental to daily digital life, before outlining major research themes currently shaping the field. Technical innovations for smarter and faster search are highlighted, including a spotlight on 3 groundbreaking papers. The session concludes with a forward-looking discussion on what's next for trustworthy and personalized retrieval. Information retrieval, or IR, serves as the connective tissue linking people to knowledge and essential services. It powers the search engines, recommendation systems, and smart assistants relied upon every day. IR is inherently multidisciplinary, merging computer science, linguistics, engineering, and ethics to address the challenge of extracting relevance from vast and complex data, spanning text, images, audio, and video. This field is instrumental in driving breakthroughs across domains such as science, healthcare, and disaster response, facilitating meaningful interactions within the digital ecosystem. The first major theme centers on the integration of large language models, or LLMs, into information retrieval systems. Recent research, such as the work by Yin and colleagues, demonstrates how retrieval-augmented generation techniques ground model outputs in real data, significantly reducing hallucination and enhancing accuracy in search and question answering. Chain of thought prompting enables these models to achieve a deeper level of understanding, adapting responses to queries enriched with contextual information. This theme underscores the transition toward context-aware, semantically robust retrieval frameworks. Efficiency and scalability are at the heart of the second research theme. As outlined by Tang and colleagues, the need for fast, resource-efficient retrieval has prompted innovations in both dense and sparse representations, each balancing speed and semantic depth. Technical advancements include mixture of experts architectures, rotary position embeddings, and memory optimization strategies. Notably, compact models such as MX by Edge Colbert v0 deliver high-quality retrieval on edge devices, enabling rapid search capabilities in mobile and emergency scenarios where computational resources are limited. The third theme highlights advances in personalization and user modeling. The RedRec system, developed by Xu and colleagues, exemplifies unified modeling across diverse user scenarios. Hierarchical models are leveraged to represent both broad and context-specific interests, while policy modules articulate user intent dynamically. Large-scale datasets like RedMMU support robust personalization, allowing systems to adapt as users transition across different behaviors and contexts. This approach aims to deliver recommendations that are more relevant and tailored to individual needs. Trust, explainability, and rigorous evaluation practices constitute the fourth major theme. There is an increasing demand for transparent and trustworthy AI recommendations. To address this, new benchmarks such as Frontier RevRec and DSE Bench have been introduced for comprehensive evaluation. These systems are designed to explain the reasoning behind their answers and suggestions, with core goals centered on faithfulness and reproducibility. This focus on transparency enables greater user trust, particularly in high-stakes decision-making environments. Key findings from the 94 reviewed papers reveal several critical trends. Specialized retrievers, such as those developed by Yin and colleagues, consistently outperform generic models in domain-specific applications. The emergence of small models facilitates advanced search on low-powered devices, broadening access. Reasoning-augmented retrieval, as demonstrated by Tang et al., effectively closes semantic gaps for complex queries. Unified user modeling approaches, like those from Zhu and collaborators, deliver personalized experiences to audiences at billion-user scale. Collectively, advances in explainability and transparency are strengthening user trust in intelligent retrieval systems. Methodologically, the field is advancing through a combination of dense and sparse representation learning, Dense methods, utilizing dual encoder architectures, excel at capturing semantic similarity, while sparse methods offer fast and interpretable exact matching. Hybrid approaches, such as Prosper, integrate semantic and literal signals to enhance retrieval quality. Retrieval-augmented generation supports output grounding in factual data, and reinforcement learning is increasingly employed to optimize both ranking and reasoning stages, driving continual improvements in retrieval effectiveness. The DM retriever model, introduced by Yin and colleagues, represents a pivotal advancement in disaster management. Specifically designed for urgent, high-stakes search tasks, DM Retriever employs a modular training strategy. Attention adaptation aligns query and document semantics. Contrastive pre-training leverages large, unlabeled datasets, and a final fine-tuning stage enhances generalization. The model achieves superior performance compared to much larger baselines while utilizing only 33 million parameters, enabling rapid and reliable retrieval on mobile and resource-constrained devices. This approach serves as a blueprint for domain-specialized retrieval in critical application areas. RedRec, developed by Zhu and colleagues, addresses the limitations of siloed recommendation systems by enabling unified user modeling across multiple scenarios. Its two-tower architecture, leveraging large language models, facilitates the aggregation of diverse user actions and contextual signals. Hierarchical representations are used to capture evolving user interests, and the massive RED-MMU dataset supports robust training and evaluation. Validated through deployment on a billion-user platform, RedRec demonstrates substantial gains in both recommendation quality and advertising effectiveness, marking a significant step forward in scalable, personalized information retrieval. The Large Reasoning Embedding Model, or LREM, proposed by Tang and collaborators, integrates explicit reasoning into the dense retrieval process. The model operates in two stages. First, a reasoning step generates reasoning-augmented embeddings, bridging semantic gaps for complex or distant queries. Second, reinforcement learning refines these reasoning pathways to optimize retrieval outcomes. LREM has been deployed on a major e-commerce platform where it excels in handling semantically challenging queries. This approach signifies a shift from traditional pattern matching toward deep, reasoning-driven retrieval, with demonstrated real-world impact. The future of information retrieval is defined by several converging directions. There will be a deeper integration of reasoning capabilities within retrieval models, accompanied by enhanced transparency and explainability to foster trusted AI systems. Domain adaptation is anticipated to expand into specialized areas such as healthcare, legal, and scientific search. Additionally, multimodal and cross-modal retrieval will provide richer, more holistic information experiences. Emphasis on real-world deployment and reproducibility will ensure that innovations translate into practical, scalable solutions. This synthesis and review were constructed using GPT 4.1 from OpenAI for both analysis and narrative generation. Audio narration is provided via DeepGram text-to-speech technology, with visuals created by Google image generation tools. All content was reviewed by domain experts for accuracy and clarity, and references for all discussed papers are included. While every effort has been made to ensure thoroughness, some oversights may remain. Constructive feedback is welcome to further refine future episodes. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.